Hi, my dear students. Myself, I'm Hatiram, working as a physics teacher. Today, I'm going to explain the rest of the questions. And previously, I was done 3 videos based on the multiple choice questions for the term 1 examinations. If you were not seeing that videos from the 1 to 80 questions, I will provide the link below of this video description. Please go through that video, then come to this video. Okay, it will help you a lot to perform well in a Cbse term 1 examination, physics, science, in science physics part. So these questions are basically for the Cbse term 1 exam model questions for physics, especially light reflection refraction part. Anyway, the 81st question is, read carefully. Two lenses of powers 3 and -4 diopters are placed in contact. Focal length of the combined lenses. Previously also I told the same kind of question. Resultant power is equals, first we have to calculate resultant power to know the focal length, that is a P1 plus P2, which is equal to 3 minus 1, which is equals to 2. So 2 diopters we got it. As is the power is nothing but 2 diopters. We know power is nothing but reciprocal of focal length. Power is a reciprocal of focal length. When we require answer focal length in terms of centimeters, we will change this formula as F is equals to 100 upon P. So 100 upon 2, it is nothing but 50 centimeters. So we will go with the answer 50 centimeters is the correct answer. So answer is this. Next, question number 82. This is a numerical. The focal length of a concave mirror. See, focal length of a concave mirror is always lie on the left side. So it is nothing but negative. To obtain inverted image means real image, 2 times size of an object means magnification is given as a -2. For real image, magnification is negative, so magnification is written as a minus v by u for spherical mirrors, which is equals to -2. This and this gets cancelled, hence v is equals to, we will get 2u. What should the object should be placed at, so we have to calculate u is equals to where it is. Then write the mirror formula. 1 by f is equals to 1 by v minus 1 by u. As a f is given, v is known, so sorry, here plus it is, so 1 by, it is equals to minus 50, which is equals to 1 by v is nothing but 2u, and object distance is unknown, so we will take it as 1 by u. Then here LCM is 2u. 2u into u 1 times, u is 2 times, so 1 by minus 50, which is equal to, this is, hence we can write as a 3 by 2u is equals to 1 by minus 50. So 2 table in 50, how many times? It is 25 times. So we can write u as a 25 3s are nothing but 75 minus 75 centimeters. So object distance is minus 75. It indicates it is placed in front of the reflecting surface. Next, focal length of lens is depends upon. This is the question. Focal length of lens is depends upon radius of curvature and refractive index of material and refractive index of surrounding medium. So answer is all the above. Formula for the focal length of lens is 1 by f is equals to so n minus 1 of 1 by r1 minus 1 by r2. This is a formula. In this, if you observe, radius of curvatures are there, refractive index of material of lens is there, and at the same time, if you write here, it is n1, then it becomes n2. So n1 is for lens refractive index, n2 is a medium in which it is present. So on surrounding medium also it depends. So answer for this question is this is okay, all the above. 84. A parallel beam of light incident on converging lens parallel to the principal axis. As we move away from the lens on the object side on its principal axis, the intensity of the light is. So parallel beam of light incident on the converging lens, convex lens on its principal axis, along its principal axis, we move away from the lens, okay, on the other side of the principal axis. Intensity of image is it, intensity of image they are asking here. So intensity of image whenever you want, then what we have to do is so intensity is first it is increases as the light is an incident at the focus. Then as a lens is a screen is moving away, then intensity is gets decreases. So this is what the answer for this question. Next, by using convex lens, a clear image of candle flame can be produced on the screen. How many times, how many other clear images can be received on the screen if only lens is to be shifted? So we will get the 2 times moreover. So here we will go with an option, the already one is formed, so one more time we can get it is as like if this is nothing but a convex lens. So if an object is placed beyond C, one image will get it. If you place between C and F, other image will get it. So if already image is formed for this one more image will get it for this one. That is between C and F, beyond C we will get, beyond C means between C and F we will get it. Next, question number 86. A convex lens of power P immersed in water. Okay, how will be its power is changes? See, whenever the lens is placed in the water, then its focal length is increases. Focal length increases, power is gets decreases. So when it's immersed in the water, what happens is power is decreases. Next, 87th, which of the given can produce a virtual image larger in size than the object? That is nothing but either concave mirror or concave convex lens. Answer B is correct here. 88 question, if you see, a lens has a power is 0.5D. It means, see, power is positive, indicates lens has a focal length is positive, that is for convex lens has a positive power. So convex lens options, we have two options. So if you go with the calculation of power, power is equals to 1 by focal length when it is given in terms of meters. So 1 by 0.5, which is equals to 10 by 5, which is equals to 2 meters. So answer, we will go with the 2 meters. Option B is correct. A diverging lens produces, so diverging lens is nothing but a concave lens, that is this lens. This is a diverging lens. So what it will produce? Always it produces virtual images, because a diverging lens is a produces virtual image. Question number 90, refractive index. So refractive index is depends upon. So refractive index n is equal to c by v. So where c is nothing but constant, n is inversely proportional to v. According to wave theory, v is directly proportional to v is equal to f lambda. V is a constant during refraction, it is directly proportional to lambda. So these two relations are clear for us. From this is refractive index is depends upon the wavelength of light used. Yes, okay, and it is a actual property of substance. It depends upon the angle of incidence. So it depends upon only one thing, that is depends upon the wavelength of light. So we can correlate this is, that is n is inversely proportional to wavelength. It is depends upon the wavelength. Next 91 question. Which of the given is not paid correctly? So which one of them is not paid correctly? Solar furnace concave mirror. Yes, it is a converging mirror. It converges at point, so it is correct. Rear view mirror is convex mirror because it always forms virtual diminished image. It is correct. Magnifying glass convex lens. Yes, when an object is placed in front of the convex lens at between the pole and focus. Okay, hence this is also correct. So all are the correct relations are there. Hence we can say none of these is correct. So again see that solar furnace concave mirror, yes. Rear view mirrors are convex mirror, yes. Magnifying glass is nothing but convex, it is also correct. So all are paid correct only. So none of this is nothing but answer. So 91%. In order to obtain magnification 0.5, okay, minus 0.5 with a concave mirror, the object must be placed. So magnification is a minus 1 with a concave mirror. So listen, as there is a concave mirror is there, this is, so magnification is 0.6 means it indicating real diminished. So object is placed in front of the or the beyond the center of curvature, then we will get the real inverted diminished image. This means diminished image. This is, so diminished image will get. So beyond the center of curvature is a exact answer for this is. Next 93. Which statement is true for the reflection of light? Which one is true? They are asking. Angle of incident and angle of reflection is equal. Yes, absolutely true. This is a true statement they were asked. The sum of angle of incident and angle of reflection is greater than 90. Always need not possible. The angle of the reflected ray less than the less brighter than the incident light. Okay, this is not true. Okay, during a reflection, in total internal reflection case, total light will come from the surface, so we cannot accept this statement. Is also wrong. A beam of light incident after reflection diverges unequal angles, it is also wrong. So answer is nothing but A is correct here. Come to the question, the question number 94. The image show the image shows reflection of light on plane mirror is, which kind of image it shows? So if you see the options, from the options, based on the image, what can be inferred, what we can conclude, that is what they are asking. Angle between the incident and a normal is greater than the angle between normal and reflected. Sir, this is nothing but angle of incident, this word up here. Okay, this is another word, they are saying greater. Then this word model indicates angle R. So according to law of reflection, if a ray of light is incident on the plane mirror, if a ray of light is incident at an oblique to the mirror at an angle, let us say I, after reflection also it must follow the law of reflection. So as I told you in yesterday's class, that is I is equals to R should be. So here greater symbol they said, so that's the reason it is wrong. Incident ray, normal, and point of incident and reflected ray must lie in the same plane. Yes, it is correct. Because this is the incident ray, this is a reflected ray, and this is nothing but a normal. Should lie on this plane only. That's the reason we can say that the B statement is correct, remaining all of the wrong. Next, 95. See this question, you can directly say the object is placed beyond C. The image is nothing but between C and F it will form. Sir, how we are saying that? If you have a scale with you in exam, so if you join this race, this is nothing but after reflection passes through the focus. This is a ray passes through the focus. It is parallel to principal axis. So after reflection, they are converging here. Hence, we can say the image is formed between C and F. This is the answer. Next question. I think it is a familiar question to you. Try to see the question. An object is placed near to the concave mirror at a distance of 1/4 of radius of curvature of the concave mirror, which ray diagram shows incident ray, reflected ray, and position of nature of image is correct one they are asking. So 1/4 of radius of curvature. 1/4 of radius of curvature. See, radius of curvature is this, then focal length will becomes r can be written as r is equals to 2f. Then it is a 2f by 4. It is nothing but f by 2. Means object is placed f by 2. Where it is showing appropriate answer, see here. It is exactly placed between the pole and focus. So f by 2 distance. Then if object is placed between pole and focus, it forms a virtual enlarged image as like this. Hence answer is a is correct. So which image represents the path of incident, which image represents the path of incident and reflected ray from the convex mirror when an object is placed at infinity. Sorry, sorry for the disturbance. So in this question, what they are asking us is when object is placed at infinity, so which of the following diagram is correct? So when a ray of light is incident parallelly on the convex mirror, if you observe properly, okay, so if a rays of light is object is infinite means rays will be parallel to principal axis. So when an rays are parallel to principal axis, this is nothing but C, this is F, and this is nothing but the C, and this is pole. A ray of light incident at certain angle, then this is nothing but normal center of curvature. If I is angle of incident, R is nothing but reflection. So similarly here also with same angle it get reflect. After reflection, they appear to meet at a point that is called focus. So this ray is incident along the center of curvature. This is, so it retraces. So this is a correct diagram. We had to identify from the below diagrams onwards. So if you'll see the diagram B is nothing but a exact answer for that question. So remaining all the are the wrong. 98. A student studies what convex mirror always forms a virtual image. That convex mirror always forms virtual image irrespective of the position. Okay, what case convex mirror always forms a virtual image? So anywhere if we place, it is always forms a virtual image because reflected rays never intersect, because incident rays retraces their path, because incident rays of convex mirror get absorbed by the mirror, because next fourth option because of reflected rays converges at a single point. So this is what the answer is, because of reflected rays never intersect at any point. Okay, they are goes in the different direction. If we'll extend them back, they appear to meet at a point. Next question number 99. 99 question. A student conduct an activity by using a concave mirror of focal length 10 centimeter. Concave mirror, he said focal length should be negative because it is lie on the left side of the mirror. He placed a object 15 centimeter. U is also lie on the left side 15 centimeter. Where the image likely form? This kind of question we can expect in the exam. So where the image will form? So 1 by f is equals to 1 by v minus, sorry, plus 1 by u. 15 is nothing, sorry, 1 by 10 is equals to 1 by v minus 1 by 15. So this 1 by 15 will go that side, it will become a positive. So 1 by v is equals to 1 by plus 15 minus 1 by 10. So LCM we can take as a 10 into 50. Okay, it will become so 10 minus 15. So it is minus 5 by 10 into 50. 5 ones are 5. 15s are, sorry, here. It is 15, not 50. So it is 1 5. So 150. This is 30 times. So image distance is minus 30 centimeters. It indicates that image is forms in front of the mirror. 30 centimeters in front of the mirror is correct one. Next, there is one more question. Is a similar question as like Rekha placed a juice bottle at a distance of 20 centimeters in front of convex mirror. So is placed, this is a juice bottle is behaves like an object. U is equals to minus 20 centimeters. Focal length of a convex mirror is nothing but it's a positive because it appear to meet at the right side of principal axis, right side of pole. So it is a plus 20. This is you can fundamentally remember, if object distance and focal length both are same, then image distance is half of the focal length, you can say directly, and that too virtual image. So inside, otherwise I will show you with calculation. 1 by f is equals to 1 by v plus 1 by u. So 1 by 20 is equals to 1 by v minus 1 by 20. This 1 by 20 will go that side. So 1 by v is equals to 1 by 20 minus will become plus 1 by 20. It is a 2 by 20. Okay, it's a 1 by 10. So image distance is positive 10. It indicates it lie behind the mirror. So answer is nothing but 10 centimeter distance in front is wrong. Focus it's a 10 distance behind the mirror is C is correct answer here. Next, Sunil conduct an activity. So this is an activity. Object height 10 centimeter. HO is nothing but 10 centimeters. Okay, and convex mirror of focal length is 20 centimeter. Convex is positive, so it is 20 centimeters. He placed the object at distance u is equals to minus 20 centimeters. Okay, what is likely to be height of the image produced? Height of image, how much is asking? So, my dear student, I already told you this is you can remember now. So, image distance from this is a v is equals to f by 2, which is equals to 20 by 2 is nothing but 10 centimeters. So, hi by ho is equals to minus v by u, where hi is unknown quantity, ho is a 10, which is equals to minus v is nothing but 10 by u is nothing but minus 20, minus minus gets cancelled, 0 gets cancelled, it is nothing but 5. So height of image is nothing but 5 centimeters. It is less than the height of object because it is a convex mirror which always forms a virtual diminish. So answer for this question is 5 centimeters height of a image. Next, 102. The image shows the path of light traveling through a glass slab. So, what case the rays of light of to deviate from its original path? So when it is deviating from the original path, he is asking change in the temperature in the air, change in the amount of light, change in the direction of wind, change in the density of a medium. Yes, this is the answer. When there is a density, optical density is changes, then speed is gets changes, then it changes from its direction. So this question also familiar question, 103. A student studied that speed of light is 3 lakhs kilometer per second, whereas speed in glass lab is 1 lakh 97,000 kilometer per seconds. What causes the difference in the speed? Okay, because only that is a difference in the optical density. Okay, glass having a more optically denser than the air, so that is the reason it is the speed of light in air and this is speed of light in the glass. That is what the difference is. Next, speed of light in air is 3 into 10 to the power of 8 meter per second, whereas what of the speed, whereas that of the speed of light in water is this. What is the refractive index of water with respect to air? This is also expected question. So refractive index of water by with respect to air they are asking. So speed they were given. So this is we have to calculate. First, my dear students, refractive index of uh, a water with respect to air. Refractive index of air is nothing but speed of light in vacuum by speed of light in air. So it is nothing but same speed will be it is 1. Whereas in case of refractive index of water, that is C by V water will be. That is 3 into 10 to the power of 8 upon 2.26 into 10 to the power of 8 will be. This 10 power 8, 10 power 8 gets cancelled. So we can say refractive index of water is equal to 3 upon 2.26. We can say as a 300 upon 226. So here refractive index of water with respect to air. Refractive index of water is nothing but 300 upon 26 to 26. Air is nothing but 1. So we can do the cancellation here. Two table cancellation you can do it. Two table cancellation if you do it 113, it is 150. So 11150 upon 113, If you do the division, we are getting nearly 1 point, it is 3 2 we will get it, because remaining two numbers are greater is there. So it is a one time only, will go in 140, this is 113. So answer is directly chosen as a C only. Next question is a 150, 105. Rahul conducts an experiment using an object of height 10 centimeter and concave lens with a focal length 20 centimeters. An object is placed at a distance of 25 centimeters from the lens. Can image formed on screen? See which lens it is. It is a concave lens. Concave lens, whatever may be the height of object, whatever may be the distance, and whatever may be the focal length, it always forms a virtual and diminished image. So it will not form on the screen. So no answer we have to choose. Two options. Image formed will be virtual. Don't feel this is a numerical. It is 100% theoretical question and conceptual based question. A student conduct an experiment using a convex lens of focal length f is equals to 20 centimeters, and an object is placed, object of height HO is equals to 15 centimeters is placed at 25 centimeters. See, this is a lens. Focal length is 20. Center of curvature will become 40. So object distance is 25. It means it is placed between C and F. 25 centimeters. Then he is asking clear image formed on the screen. Yes, absolutely will form. It is nothing but a real and as well as a erect inverted image will be formed on the screen. So answer A is correct here. Next, Rocky conduct an experiment to produce an image of an object on the screen which is placed 20 centimeter from the lens. She used convex lens of focal length 15 centimeter for this experiment. Where should she place the object in order to get a sharp image? So she want on the screen, no? So if she will place, if this is a lens, so focal length is nothing but they given in the question, focal length is 15, center of curvature will become 30. Object is placed is at 20 centimeters. So what is asking a sharp image where he will get? So sharp image he will get between C and F. Beyond C will form. Beyond C means number should be greater than 30 here. After 30 will form. So after 30, it is nothing but only one option is there. 30 centimeter front of the lens. This is what the answer is. So in that way, some questions will be which are tricky based upon the concept and doesn't involve any numerical part in it. So the question number 108, an image of an object is produced on the screen about 36 centimeters using a convex lens. The image produced by about 3 times size of an object. Then what is the size of an object? That is the question. An image of an object produced on screen. So magnification is nothing but -3. So minus V by U is equals to -3. Minus minus cancel. V is equal to 3U. So here object is produced and screen which is about 36 centimeter using a convex lens, means image given. Then we have to calculate a size of an object. Wait a moment. If they are asking the size of an object, yeah, this is a object is placed on the screen so that it is produces, this is nothing but height of image, then height of object they are asking. So in that case, it is on screen, so it is negative will be, no need of image distance. So m is equal to -3, hi by ho is equal to -3, where it is a -36 by ho is equal to -3. Minus minus cancel, 3 ones are 3, it is nothing but a 1 2s are, so hence height of an object is 12 centimeters. This is what the answer for this question. So height of object. Next, an object of height 10 centimeter is placed in front of convex lens using a focal length 12. So the question is, I'm writing here, answer is, so an object of height is 10 centimeters, height is 10 centimeters, is placed in front of the convex lens of focal length is nothing but positive for that lens. The object is placed at a distance of 36 centimeters in front of a convex lens. So object is placed at 36 centimeters in front of the lens. How many times the image is likely formed? So they are asking hi is they are asking then we have to calculate v. 1 by f is equals to 1 by v plus, sorry, minus 1 by u. 1 by 12 is equals to 1 by v unknown, minus of minus object distance will becomes a positive 1 by 36. This 36 will come this side, then 1 by v is equals to 1 by 36, 12 minus 36. So LCM 36, 3 minus 1, 2 by 36, or we'll get a 1 by 15 is nothing but a image distance. So image distance is nothing but 1 by, sorry, 15 centimeters. They are asking a magnification. So for that hi by ho is equals to minus v by u. So here hi is nothing but hi, how much? Hi is 36 by, sorry, object, hi is unknown quantity, sorry for that. Ho is ho, height of an object is 10, which is equals to, this is length, no, positive will be, this is v is 15, we got, by, why we got 15 here, focal length 12, object is placed 10 centimeter between pole and focus, sorry, 36 centimeters is nothing but object distance. So as to get the image distance is nothing but 18. 18 we have to get the image distance. Somewhere it is, sorry, yeah, 18. 18 is the image distance. Image distance is 18, and object distance is nothing but u is equal to minus 36. So 1 by 2. Here we will go 10 by 2. It is how many times. So no need of this is just magnification. If we will calculate enough is equals to 1 by 2. 18 by 36 will get as a 1 by 2. Height of image is nothing but 5 we are getting. Height of image is a 5, and magnification is nothing but 1 by 2. So here how much times magnified means half time magnified is nothing but answer. A student conduct an experiment using a convex lens. He placed the object at a distance of he placed the object at a distance He placed an object at distance 60 centimeter in front of the lens and observe that image formed at a distance 36 centimeters behind the lens. What is the power? So first to calculate the power focal length for this is, if we use the lens formula, so 1 by f is equals to 1 by v minus 1 by u. So from this is a 1 by 30 of image distance and minus of minus with plus becomes object distance 60 given. So from this is we'll get focal length as equal to 20 centimeters. Power is equals to 100 by focal length, that is 100 by 20 we'll get as a 5 diopters. So answer is a 5 diopters. Okay, my dear students, I hope this video is clear. Okay, please go through the all bits. If you want any kind of concept, then give me the message so that I will post you the answer for this any kind of concept to you in the form of these videos. Have a nice day. Great to meet with you. Thank you. Bye.